Yeah, so I hope everyone can be able to see my screen. So let's allow me a bit to, let me just go up. So I picked on Rwanda, Kivalon. So that was my project. So first things first was to load the libraries that I would use in doing the data analysis, which I did. Then the second was to read the data. That was the Kiva. So I did that, uploaded everything, then uploaded also the regions, locations, the themes, long themes by region. Then I went straight. That was just to allow me to, to see some description about the equivalence data for the numerical features that were present. Then I went to subset the Rwanda data. So after subsetting the Rwanda data, I ran just to see what was contained in the data, which is displayed here. So then that is what we got. You can see the columns. We have the region, funded amount, loan amount, activity, the sectors, terms in months, borrower's gender, lender count, repayment interval, and use. Then I went into trying to understand the data more. So I ran rwanda.info just to see what data was here. So I got the columns, which was, there were 9 items in these columns. So, but the total columns should be 10 because it starts counting from 0. So they are 10. So after getting this, I also tried to run to see if there are some missing values in that data, which I got. There are some missing values. So like the region, the borrower's gender, and the region column contains some missing values, as you can see displayed. I will jump this one because I was supposed to run this somewhere after I'd done some analysis on borrower's gender. But when I ran this, after I did that, so I got no single column had no missing value. So this was a great aspect to our analysis. Then I checked on the total missing values, which there were 6,138 missing values on the region column, as displayed here, 14 on borrower's gender, and 15 on the use column. Then I had to create a copy of the data frame and to start working with a new copy. So when I ran that, that's what I got. You can see there are some missing values. Then I went straight to exploring the numerical values by using describe function. So then we got this data, and I tried to just look at what were the mean, standard deviation, the minimum and the maximum loan given. There were then the percentiles, just to check how the data looks like. So I got the maximum loan given was about 50,000 US dollars, which you can see at the maximum here. Then the longest loan term was 41 months. Under the loan term months, you see it is 41. Then the lender count maximum was 1,302. Then after that, I moved straight away to data exploration. So then I checked on the top sectors in which more loans were given during that period. And I ran this data, and we plotted the figure, and what we got here was that the food sector was topping. In that order, there was food, there was agriculture, retail, clothing, all the way down to the wholesale. So I made a comment here and said the food sector is very frequent, followed by agriculture in terms of number of loans. Because you can clearly see, if you look at this data, food, if you run down, you see it is above 2,000, so which is 2,269 under food sector. So that is the top sector in which more loans were given at that particular time. Then I went ahead to look at the types of repayment intervals. So under repayment intervals, I did this with the value counts. So there was a type of repayment intervals with the accounts. So when we plotted that, what we got it was that the irregular topped the list, followed by monthly repayment interval, then the bullet, which again we plotted. I plotted a pie chart on the same, and you can clearly see the repayment interval that were irregular was topping, followed by monthly, you can see by the sizes, and then lastly by the bullet. So irregular was more frequent, then monthly, bullet were less frequent. Then I went straight and did an histogram just to check on the same, and you can clearly see that still this was being displayed the same. You could see the irregular and the accounts. So if I put this, you could see the lender count and the repayment interval and the number of counts. Then if you go to the monthly one, you could see the count and the repayment interval. And the bullet was highlighted in green. So I gave them some colors so that is to differentiate them. You can also see the count and the repayment interval. So this allowed me to able to reduce that the irregular loan repayment was more frequent. Then I went and did a facet column, as you can see. So the repayment interval, irregular, you can see, and the lender count. You can also see a repayment interval, which was for the monthly and the lender count, and also for the bullet. So after that, I moved to most frequent regions that got loans. So I plotted the bar graph, most frequent regions for Kiva loans and the region names. So you can see Kigali was topping, which got about 300, followed by Rulindo in that order to Musanze. So you can clearly see that Kigali is the most frequent region that got more loans, followed by Rulindo, as shown by these the bars. Then I did a small order of columns. I'll jump this for the moment to see just the columns to help me do my distribution. So I did the distribution of funded amount, and when I plotted this, you can clearly see this is density and funded amount. You can clearly see how the distribution is in this place. You can see there are some outliers in this data under the loan amount distribution. So I deduced this was a normal distribution. The funded amount is the graph is skewed to is positively skewed. That is, you can see to the right. So that means that it's a normal distribution, a bit normal, but you can also see there are some outliers here that we need to deal with in this data. Then I went and did also distribution of loan amount. You can clearly see how it's also distributed. There are still some outliers on the same. So I commented we can detect outliers in the data set in the loan amount distribution. So then I went and did distribution of Rwanda regions. I think this is more or less the same thing, but now what I did here was to just do more of comments. So as you can see, Kigali region got more number of loans. You can see, followed by Bugesera, Masaka, Muhanga, in that order, was less frequent regions based on the number of counts, which you can see shown in this graph. Then we went ahead and I did a distribution of loan activity types. So here is where the use came in. So the activity name and top loan activity and the number of counts. So you can see top two loan activity which got number of funding are farming and food market. Farming is here at 976, followed by food market at 736. Then I went ahead, so did a distribution of terms in month, number of months over which loans were scheduled to be paid back. So I read the data, and we got about the number of months which loans were scheduled to be paid back was 39, based on this data. Then I did the distribution of number of months of which loan was scheduled to be paid back. And this is clearly what you can see. So these are number of months, again is the count. So you can clearly see on this chart that the 6 months over which loans was scheduled to be paid back took the highest times, followed by 8 months and 10 months in that order. Is my time over?
Yeah.
It's over. Hey, okay. There's a lot. So let me just rush over and finish up.
You'll just share them because we have one more person.
Okay.
Yeah, we have one more.
I thought I was the last person. Okay. Anyway.
We still have Shem.
Okay. So my data was huge. I didn't follow any format what was given. I went ahead because I felt I needed to learn more. So I went ahead and even just to run over, I even did the Rwanda map box. I did the map box. You can clearly see what is here. So you can go by these regions in Rwanda, just highlighting them. You see, then I did a summary of the same, but I'll share. So my data had a summary of the same. So thank you.
Yeah, that was nice. Very nice.